So our next exercise is a real world problem. We are given the absorption rate of a drug, which is given by this function R. And in part A, we must find the average rate of absorption from t equals 2 to t equals 5. And the average rate of absorption is of course nothing else but the integral average of our function R. So let's just try that. We have the average of R from 2 to 5, which is of course just 1 over 5 minus 2 times the integral from 2 to 5 of our function for t times e to the negative t squared. Now here we have definite integral, so first we must find the indefinite integral of this function for t times e to the negative t squared. Here we can see that we have a product of two functions. One of them is elementary, the other one is composite, and the inside function of our composite is negative t squared, the derivative of which is negative 2t, which contains t, so we must use substitution. So let's denote our inside function by u, so u equals negative t squared, and this gives us du equals negative 2t dt. And we can see a t dt here, so let's rearrange the inside of our integral. So we have integral e to the negative t squared times 4t dt. Now we can see that here we have 4t dt. So to get the same here, let's multiply by negative 2. So we have negative 2 du equals to 4t dt. And now we have the same thing in both places, so we can do the substitution, giving us negative 2 integral e to the u du, which is of course nothing else but negative 2 times e to the u plus some constant c, and let's write t in the place of u to get negative 2 times e to the negative t squared plus c. And now that we have our indefinite integral, we can find the average using the definite integral, which will be 1 over 3 times, let's take the primitive function, negative 2 times e to the negative t squared, evaluated at 5 and 2, and of course taking the difference. So this gives us 1 over 3 times negative 2 times e to the negative 25 minus negative 2 times e to the negative 4. Now we are done with part A. In part B, we must determine the function that gives the total absorbed amount beginning from the moment t equals 1. Of course, this means that we have to find the integral function of our rate of absorption with the constraint that in 1 it must be 0, so capital R of 1 must be 0. And of course, we know that the integral function will be capital R of t. The definite integral from 1, because it must be 0 at 1, to t of our absorption rate, and we will use x here because we already used the letter t in our integral function. So let's finish it with dx. And now we must find the primitive function, but in part A we already did that. But here we used the variable t to get this primitive function, so we must be careful that we use the variable x here, and this gives us that we have the primitive function negative 2 times e to the negative x squared, and we must evaluate this function at t and 1, take the difference, these two. And so we have negative 2 times e to the negative t squared minus negative 2 times e to the negative 1. And now we are done with the exercise.